is there a future for democracy, actually, in these times of big data and AI? And I will argue that perhaps democracy, if we just upgrade it in a suitable way, could be better than optimal. So that's a bit provocative, but with optimal, I mean based on some optimization algorithm. And of course, not everyone needs to agree over here. This is really open for debate. So as you may know, a couple of years ago, big tech companies have basically suggested that we should move fast and break things. And basically, it was about reinventing the world as we knew it. And also democracy was up for debate. Why is that not working? I don't know. So basically, democracy was called an outdated technology. It's strange, there's battery. And this is not working. Okay, anyways, I'll have to do it manually then. Democracy is an outdated technology, was suggested. It has brought wealth, health, and happiness for billions of people all over the world, but now we want to try something new. Now, I've been writing about the perspectives of big data and AI-based society already back in 2015. And I basically suggested that there would be an automation of society, but there were two ways to do that, top-down or bottom-up. And I came to the conclusion that a bottom-up approach, considering the complexity of the system, would be a good way of doing it. So I suggested we need to basically upgrade democracy and also capitalism in order to address the sustainability challenges that we face. Basically to survive in a sense. And then in 2015, what people called the Digital Manifesto came out and was published then also in English quite some time later on, a year later, basically, even more than that. And it had this title, Will Democracy Survive Big Data and Artificial Intelligence? And some people thought yes, and other people thought no. So that's asked basically ChatGPT on the future of democracy. So it says there are a couple of challenges to democracy, like manipulation, disinformation, privacy concerns, algorithmic bias, concentration of power, job disruption. There would also be opportunities for democracy, such as enhanced decision-making, accessibility, transparency and accountability, and predictive policing. I would have put it there. And that's what GPT thinks. And then we can do a couple of things to preserve democracy, it says, and this includes regulation, ethical AI, education, civic engagement, and transparency, among others. Okay, I'll not go into all the details because I want to talk about our research, and I'll still try to activate this remote control. Of course, that would be so much better if that would work. So the question is, what is the problem that we need to address? Basically, there's no question we are living in a time of big data, and that's altogether a good thing. The question is just how should we use the data? And in the beginning, basically, people thought that big data will just tell us the truth. We'll just need to look into the data to know what's going on and what we should be doing. We would see what is wrong, and then basically be empowered to fix the broken system. It turned out to be a pretty naive perspective on big data. And also, often it was voiced that if only we had more knowledge and power, then we could solve all our problems. If only we could predict and control things better, And so people have been working on using big data to control and predict systems. And there are many books like this about ways how to rule the world in a sense with big data and AI. And that was very much exciting. A couple of people, I thought, okay, everything we need is big data, more data, as much data as we can get. And you know that basically secret services and companies and governments and militaries around the world, basically everywhere have started to collect a lot of data. That's not a secret. The question is now, how well has it served us? Are the problems solved? The answer is no, not yet, at least. And this kind of technology also enters our cities. So everyone talks about smart cities, and it has a good connotation. We are also doing research on smart cities, so it's not a bad thing. But what would you guess how many smart cities are there in Europe?
That's the definition, let's say.
Sure.
But dozens.
Dozens? Anybody else?
Three.
Three? Renato? Yeah, can you know that? Zero. Any other points of view? Now, this is a brochure that I found on the service of the European Commission and says 240 European cities. And that's kind of surprising because most people will have difficulties really naming just 10 or just 5 smart cities in Europe. And basically shows that we know nothing about what is really going on. There's not much transparency, even though we can safely assume that every city has started to collect data about a lot of things. So city life gets under a microscope. And companies, of course, is very much interested in this. And the question for them is, could cities now be run like a business? This idea has been around many times. Or could it even be run like a machine? And I should say right away, by now, the conclusion is that both approaches don't work well enough. But there are certainly these desires basically to try out new forms of society, to have experimental grounds, not just in a laboratory based on ethics approvals, but basically really to make large-scale real-life experiments. Larry Page, for example, has voiced that. He is certainly not the only one. And they were also, Google at that time, a company that was actually making experiments, right? They were going out, in this case, in Toronto, Canada, and were basically together with Sidewalks Labs, trying to build a digital part of the city. And people didn't like it. So what went wrong? It's probably the reason why there's not much transparency about smart cities in Europe and other places around the world, because this experiment went wrong. But I think we should know more. Okay, I'll make a little excursus, but that fits well the subject of smart cities, and we'll talk about the control of traffic flows, because we learned some really interesting things over there. So in many cities, you find a situation like this. There's gridlock, there's a lot of traffic jams. And on the other hand, I've made this recording at some time in Egypt. Why doesn't it work? It's really strange. I think I'll restart the presentation. And perhaps that solves all the problems. It would be so easy to tell ChatGPT just to make it work, but it's just not working. Anyway, so what we found basically in the city was that there were designs of intersections where self-organization would basically make things work in a beautiful way without traffic lights, police, courts, and so on. And it's really just a matter of design. And this was very inspiring to us, and we thought, could we basically create green waves, not by imposing a certain pattern on traffic flows, but basically based on self-organization. And this was inspired by an observation that we made with pedestrians. And it's really a bit annoying because all the videos don't play. That's really so fine. So what we found in bottlenecks is oscillatory flows. And those oscillatory flows happened even without a traffic light, without regulation, just based on self-organization. So what happens is that it will accumulate on the side that has to wait, and then eventually they build up pressure that turns the tide, and this creates those oscillations. And the idea was that basically we could use those oscillations in order to define traffic lights, because intersections in a sense are also bottlenecks. And for this, basically, we wanted to make measurements of outflows from road sections, but also of inflows. And that has the advantage that we can make a short-term anticipation of vehicle arrivals. And this is very useful information for adaptive flow control. Now, what we did is we compared basically 3 different ways of controlling traffic lights in a city. The approach on the left is the most common approach right now. There's a traffic control center that tries to get as much data as possible about the traffic situation out there and tries then to come up with an optimal control scheme that would be imposed on the city like by a benevolent dictator. In the middle, we have basically an economics approach where each intersection strictly minimizes travel time based on the inflows on the approaching road sections. Like every intersection is like Homo economicus and strictly does the best, but does not care about anybody else. And then on the right-hand side, we do the same, but if there's a long vehicle queue on the road, then we first clear it before we go back to travel time minimization. So traditionally, based on what we have learned, we would say this is the best because this is going to coordinate traffic flows. This is the second best. And that is the third best because it's friendly with regard to others, and basically that gives you some disadvantages. However, let's see what really happens. The red line over here is for the top-down regulation by the traffic control center. So as the capacity utilization means traffic volume goes up, the queue lengths of vehicles behind the red lines also go up, as expected. Now, interestingly, the Homo economicus approach, the selfish optimization, works much better at low traffic flows because every single vehicle gets just the green light as it approaches the intersection, does not have to wait at all. But when there are many vehicles, you can't do that, and then suddenly the violet curve shows you that queue length explodes and things get out of control, and that's why a traffic control center would be better for high traffic flows. Now, interestingly enough, the third approach, the other regarding approach, that turned out to be better all the way. It creates coordination, and it's basically taking care also of neighbors. And if everyone does that, basically, this is beneficial for everyone. Yes?
These are simulations, and these are actually tried out.
These are still simulations. And then we said, okay, we'd like to try it out in the real world. And we spoke to the traffic control center in Dresden, and they said, oh, we're actually happy with the traffic control we have. Just bought a new state-of-the-art system, cost a few millions. It produces green waves, even adaptive green waves. So the only thing that we have, which we're not happy about, is that in the very center, we cannot prioritize public transportation. If we do that, basically it interrupts the green waves, and that will produce monster traffic jams, and that's why we can't do that. So they said, if you think you're smart, then come up with a better solution. What even makes things worse is that there are a lot of buses and trams that cut through this very irregular road network in very different ways. So they really can disrupt the traffic flows a lot. Still, what we did is we basically gave buses and trams a higher weight than vehicles, say a 50 or 100, like the number of passengers in those buses or trams, right? And then this came out. On top, you see the green waves that were imposed by the traffic control that the city bought. And on the bottom, you see the adaptive scheme, the self-control scheme that we developed. It also produces green waves, but they're less regular. And the question is that good or bad? And it turns out to be good. It turns out to be good for public transport. A huge improvement. Prioritization works. But also, car traffic actually has benefits, and pedestrian and cyclists too, and by the way, the environment as well. All right, so basically, a couple of years back, we already said that with intelligent traffic lights, we could actually improve climate. And the trick to get there was basically a basic democracy for traffic lights. So the traffic flows should control the traffic lights rather than the other way around. That was the conclusion. And at that time, there was a discussion around this here in Zurich, and there were huge newspaper articles like this one. And so it says, the revolutionary idea of the professor, traffic controls the traffic lights. And it didn't happen. It was turned down. And why? Because the city was afraid that it would work too well. I've never heard such a thing. Okay. Then it took a couple of years. And what happened is that my previous PhD, who did the work on this, Stefan Lemmer, together with the guy who previously ran the traffic control center in Zurich, they jointly established a company. They established a company, and then the third was interested actually in trying things out. All right. So basically, they did measurements before, then they implemented the project, and they did measurements afterwards, and then they compared the measurements, and thereby they could say how well things work. I was personally not involved. And things happen over here, right? These are the intersections. You can just see part of it. And that looks okay. But if you look into the technology that is below the surface and that needs to be considered in traffic light control, then you see this is actually quite challenging. And this is just part of the system. There are several intersections. I just showed you this because it's already complicated enough. Thank you. All right. Then an institute at ETH Zurich was evaluating all this. I did not even know about this at that time, so it was totally independent. And that was the purpose of the evaluation. And it turned out to be a very positive evaluation. Here you can see the change. Before, on top, the green wave that they had. On the bottom, what happened with the self-control approach that we developed. You can see the red part, which are the traffic dams, are reduced quite considerably. And what does that actually mean for different modes of transportation? Everyone benefited, surprisingly enough. Pedestrians, public transportation, and also individual traffic, both cars and bikes. And so the conclusion was what they then called the super traffic light managed to produce more green for everyone, as the headline says in small font. Something that sounds like just an impossibility. So how is this possible? Well, the point is the traffic control center makes the best effort to optimize traffic flow, but it's an optimization problem that's so-called NP-hard. That means the complexity of the solution, the number of possible solutions explodes with the number of intersections. And even for a medium-sized city, a supercomputer could not find the optimal solution in real time. What you can do is you can come up with an optimal solution offline for a typical traffic situation, say Monday between 10 and 11 in the morning, or Friday between 3 and 4 in the afternoon, or when a soccer game or a pop concert is going on. And then you take this optimal solution and apply it. But traffic flow varies a lot. That means you have an optimal solution for a situation that actually never occurs. What we do instead is we create a, perhaps not 100% optimal solution, but say 90%, but it actually fits the situation that is there at this time, at this place. So it's adaptive. It uses gaps in the flow as opportunities, and this is how it basically comes up with solutions that make everyone more happy. And the conclusion was that we cannot control everything top down. So what does that imply for society altogether? And of course, we've been thinking about this already some years ago. And we were aware that societies are complex dynamical systems that would have similar kinds of problems. And therefore, we would need a management of complex dynamical systems tailored to such kind of systems. And anyway, the world becomes ever more complex as we go on networking the world. So I mean, the world becomes a different kind of world by networking, by becoming more complex. And I said, basically, we need to have digital democracy. We need to upgrade democracy digitally. A couple of years later, actually, German president said, we need a democratization of the digital world. And again, a few years later, the G7 decided that AI had to become basically prepared for democracy. And it should basically support human rights. It should support privacy, the rule of law, and it should be human-centered and democratic. And then the question is really how to do that. So we started basically working on this question, how to make best use of big data and AI, together with a PhD school that was coordinating in Delft. And out came this concept of responsible engineering And design for values, the assignment for values was actually around already before, but the question was how to really apply it to society. And just recently published a paper called Democracy by Design. And there give a couple of prompts what we think is important. In particular, if you create a piece of software, then there are many design decisions that you need to take. You should always judge them based on whether they're more or less democratic, good or bad for democracy. And we propose that you should go for the more democratic solutions. So what are democratic values then? Human rights, dignity, freedom, self-determination, pluralism, and so on, checks and balances, division of power, fairness, justice, legitimacy, and so on. So there are a lot of them. It's a challenge how to design systems this way. And informational self-determination would be part of it, and it requires basically new platforms to administer the personal data collected about us, giving us back more control over our own data, while it would be possible also to do statistics needed for governance of societies, all right? Freedom of choice also, I believe, is important. Of course, you can automate now most systems with data and AI. But we don't have to do this. Or we could kind of automate it to some extent, but still leave us freedom of decision-making. So basically, the clear yes and clear no cases AI could take for us. Why should we waste time on that? But the more debatable cases where we need to ponder about, here we should have free choice. And in fact, you know, there are some things in our life that we would not want to hand over control to machines, like the friends we choose, the family we establish, and these kinds of things. Perhaps also the job we choose. So here, basically, those systems should give us the possibility to take our own decisions. Now, I think democracy is furthermore about enabling distributed knowledge and collective intelligence. Nobody has the full picture. Nobody has the solution for all our problems. But together we can see more clearly. And digital technologies which help us basically put this knowledge together in an unbiased way and support collective intelligence. So say in astrophysics, for example, you have on the one hand those huge antennas, but actually more powerful is it to have an array of many smaller antennas. And this is kind of the picture of how I perceive democracy in a sense, in a very oversimplified way. It is true that we're coming from a time where we do not have enough data to take good decisions. We're now in a big data age where we can take evidence-based decisions, but things are more complicated than that. Processing power is increasing exponentially, doubles about every 18 months. But even though we have the best technology ever and more data than ever, things seem to get out of control. And why is that? Now, first of all, data doubles even faster than processing power. It used to double every year, which means that in a year we produce as much data as in all the years before in human history. Already unimaginable, but it's going to be 12 hours rather than 12 months. And in other words, we'll never be able to process all that data. I call this dark data. We need to know what data to process and how. That requires scientists and science again. We cannot just fully automate that. Plus, as we go on networking the world, systemic complexity explodes even faster namely in a combinatorial and not exponential way. And so paradoxically, we are losing control, even though we have the best technology ever. How to use that technology. And we believe we need a new control paradigm, basically distributed control. And this is where bottom-up and self-organization come in. And self-organization does not mean everyone just does what they like, but rather that we need interaction principles and rules that create coordinated and cooperative behavior, and this can be digitally assisted. Okay, so basically the idea is to have a new paradigm to go from control and manipulation to empowerment and coordination. And that brings us to swarm intelligence, basically. Right? Everyone is really fascinated to see those swarms of birds, how do they each have airplanes. It's never been such a thing. It's too dangerous. And then we have these heaps of ants. And by the way, in such a heap, the neurons of all the ants amount to approximately the number of neurons in a human brain. And they run an entire ant society on it, which is actually differentiated and really complex. And it all works beautifully. And there was already this idea to run society like a beehive more than 300 years back. And then the question is, how do bees actually do that? So there are, of course, scientists have been looking into this in much detail. And so bees swarm out to find food sources, and then they come back and report to all the others. And their excitement depends on how much food is out there. The direction of their dance basically indicates the direction of the food source. But there are more things to consider. And similar phenomena are also known from humans if the conditions are right. And then we speak of collective intelligence or wisdom of crowds. Of course, there can also be a madness of crowds if those conditions are not met. And so basically, we think that collective intelligence should be one of the guiding principles and basis of digital democracy. And the issue is really how to bring the best ideas of many minds together. And those are three things that matter. Collective intelligence, as we know it also from these, is organized in at least three phases. Independent exploration. The important word here is independence. That means the participants should be diverse and they should not be manipulated. Unfortunately, any search engine search on the big search engines are all personalized and manipulated. So we cannot really independently search easily anymore. Phase two, everyone comes back with information, ideas, and solutions that they found and exchange those ideas. And then in phase three, there's a deliberation going on and an integration of ideas and solutions to come up with even better solutions. And in fact, this works so beautifully, you can't almost believe it. There are many examples. One is the Netflix prize, and basically Netflix wanted to have good recommendations of new movie series to their customers, and so they were rating or asking people to rate the movies that they have seen, and then basically they were trying to come up with good recommendations, and they said, we want to be better than that. So here is $1 million if you can improve our algorithm by 10%. And it took many months to get this 10% improvement because Netflix was not a stupid company. They knew how to do big data mining, right? And then eventually what worked was that the best performing team was combining their solution approach with the second best and third best approach. And it did not deteriorate the solution quality, but it improved it. And they managed to jump over the 10% line, and they won that competition. Then other teams also put their solutions together, and they were also almost equally good. They also jumped over the 10% line. So combining solutions is, when it comes to complex problems, a very promising approach. And this is a scientific book about these kind of things, how the power of diversity creates better groups, firms, schools, and societies, right? So what needs to change? Now let's go back to this benevolent dictator approach, because this is also an approach that's often being discussed in connection with international politics, where we have those global problems to address, and we have those huge databases. So could a social engineer equipped with all that data about the world do the best thing for us, like a benevolent dictator? So what would probably the approach be? A benevolent dictator approach prefers things to be plannable, predictable, and controllable. And some people have even proposed that we could go so far that we would be living in a post-choice and post-voting society, because there would be so much information about everyone that why should we ask people at all? You know, if we already know what they like. This, of course, is not well compatible with democracy and freedom, but it could still be better than anything we have, right? So let's see how well that scenario really plays out. So the possible procedure of the benevolent dictator would be determine individual utility functions, and we use mass surveillance to figure out your preferences, basically in all detail. Then determine an average utility function from that, find the optimal solution for that utility function, and then implement it. But here we have the same problem, like why the traffic control center was not really coming up with the best possible outcome. Because you have an optimal solution for a typical person, an average person, but perhaps this person does not exist. So an average utility function serves many people not so well, and sometimes even quite badly. Goal functions, which are the basis of optimization procedures, are one-dimensional. But societal needs are multidimensional, and we want to increase prosperity, sustainability, health, education, culture, and many more things, right? So can optimization really do that? Is that the optimal approach, even though it sounds like optimal? Goal functions actually oversimplify societies and their needs. So the question is, are there other ways to decide? And the answer is yes, vote. When we vote, we don't have to agree upon a certain utility function. Everyone can have a different utility function. Just vote for what you think is good for you and perhaps others too. Okay? There are some issues though. The most common voting scheme, called majority voting, is actually one of the worst voting methods, as it turns out. There are various issues. One of the concerns that people often voice is the tyranny of the majority. I mean, 51% would basically tell 100% of people what to do. And it may not fit the 94% very well. And then actually fairness is an issue. And you see that also in terms of spatial fairness. Let's take a city as an example. A city has many districts. And as it turns out, decisions are often taken in a way that those districts with the most people are overweighted. So most of the money goes there. It's typically the center, and the periphery gets less money. And then you get the situation, as you know it from France and many other countries, where you have a beautiful center and banlieues with a lot of social problems around. So there's no spatial fairness. And over many decades, it's really becoming an explosive social problem. So we need better voting rules. And this is actually where Josh comes in. So Josh, would you please take over? Because Josh has been, oh, it doesn't work. Oh, now it works. Okay, better voting.
Hello. Well, I'm a PhD student in the X team. My name is Joshua Young. And why do we look into voting? And the way I perceive voting is that we have this kind of democratic system. Usually it functions, sometimes well, sometimes not so well. But you can consider voting as a kind of sort of human in a loop design element in the democratic system. Every now and then, we interrupt the system for a little bit, and we have our input, the human input of the system. And this is why we want to investigate how voting works. And here we have general preference, citizen preference, and there's actually two aspects to voting. One is how we cast our votes, and that's, for example, if you only tick a box out of the 6 options, or you have multiple points to distribute. There's different formats to voting. And vote aggregation refers to how these outcomes are aggregated. So usually when we just talk about majority voting, obviously you have just, the highest candidate that received the highest vote that would win the election. But there's all types of different election, and voting aggregation can actually make a significant impact on how the outcome is calculated. So at the end, we want to ensure that we have a democratic outcome. And the team has been developing some different experiments. And for example, one of them is a vote app, and they enable participants to vote in different ways and see how that influences the collective outcome. And in this particular paper, they look into how people respond to COVID questions differently. And that's the paper that I was referring to. There's a couple types of different voting inputs, and I'm just going to offer a few examples. For example, actually, I will just provide a little bit of context that there's why are we looking into different types of votings? Because traditionally we have sort of candidate-based politics. So people look into like, oh, there's 2 candidates and I only want to choose one or the other. But with digitalization, people's attention and focus and the societal needs have been much more complex than it was in the past. So then the opinion has been fragmented, but then our voting ballot does not reflect the needs of this kind of multidimensional social needs. So we explore different voting inputs so that people can express their preference differently. For example, why do we only need to choose one single option in an election? We can have multi-winner elections so that multiple preferences can be reflected in the outcome. So one of the voting options is, for example, this is an easier one. This is approval voting. And then, or you can approve, disapprove, abstain, or just rank different options. If your first options didn't get in, and potentially your second options will be considered and translated into points. This is the border system. And now people are exploring this kind of different types of credit-based voting, and that also enables citizens to be able to sort of describe their preference according to the intensity. And there's also, for example, in the blockchain community, there's quadratic voting, where people have 100 points. And then if you want to put more points into one particular option, then it will cost you more. And that sort of changes people's behavior and make sure that people allocate points more fairly and consider other options. So voting design can significantly also influence human behavior and human decisions. And then when it comes to voting aggregation, we're looking to the case of participatory budgeting. And this is a very interesting case because if you think about general collective decision-making, there's always different needs and also different costs. You have a cost constraint. And participatory budgeting is a classic example. For example, a city allocate, say, $1 million to this, for the citizen to decide what projects they want to prioritize and what projects they want to vote for. And so we want to consider that, for example, there's cost in all different options, where whatever you choose. It could be your team deciding on what magazines to book, or your group deciding what pizza to order, right? So when it comes to vote calculation, like a simple, this is what usually happens in a normal city, that the highest vote get approved, but usually they don't take into cost into consideration. A very expensive project can actually fund multiple options, and we want to be able to actually put that into consideration. For example, one of the options being, if you have some sort of cost versus vote ratio, and then you rank them according to that, and then select these options that's sort of much more efficient, much more effective. And then there's also another way that's called a method of equal share, and that essentially distribute citizen budget equally to each citizens, and they use their money to vote so that you can fund the projects, and then the projects will be funded when they receive enough funding. Like I said, voting aggregation can create very different outcomes. So this is according to the same sets of votes, but with different voting aggregation methods, then you can fund very different projects. For example, in a normal simple aggregation, we have most of the budget on one project, but in a different kind of calculation, you can actually fund a lot of smaller projects in the city. And this is the paper experimenting on the design voting system, digital voting system. And we sort of have different combination of voting inputs and voting aggregation for participants to try out. 180 participants try out different voting combination, and we see how the collective outcome is influenced. And we also try this in the city of Adelaide in the participatory budgeting program. Their first, and this actually was implemented this July. And so citizens of Adelaide actually voted altogether. At the beginning, they proposed projects. And for example, this is your idea, the citizen ideas. And then there's the process of collective intelligence where they come together to decide on citizen initiatives. And then they prioritize what they should bring forward to voting. There's idea integration. And then they discuss whether they can work together or not. So the workshop took place around March this year. And they talked about what the budget should be used for. All right. So, and people proposed a lot of interesting ideas. And, you know, we also developed different ways for people to deliberate and to discuss together what they prioritize. And at the beginning, there were a lot of ideas because we set the bar very low. 161 ideas was proposed. And then slowly through the collective intelligence process, sort of like people, there's idea integration, and eventually there's also the policy check, like the policy group, make sure that everything is according to law and also doable. And then eventually 17 projects won the budget. So a lot of projects are being built in the city of Adelaide because of this participatory budgeting program. A lot of fun ideas. I really love the summer night in the body. And we also try out different ways of explanation because we realized that when it comes to this kind of different ways of voting, the core of this process is trust. Trust and transparency. There's different ways of explaining, and we experiment with these different explanations and how people perceive these explanations. Well, in the participatory budgeting, we use accumulated voting, so 10 people can distribute 10 points. So minority can protect their preference. If you care about one particular issue a lot, then you can put 10 points in one issue. And if you just be a general voter who care about a lot of things, then you can also distribute your points fairly. And the voting aggregation actually influenced the way they formulate their projects. So for example, we told them that the higher you want, the higher budget you propose, you also need more support, and which is very intuitive. But then when it comes to simple majority vote, then this is not really taken into consideration. And the same thing happened in Zurich last year, 2021. And all of the project proposed at the higher, like not 80% of the project proposed their budget at the highest maximum, because there's no disadvantage of proposing a much more expensive project. This is one of the ways that we're explaining the votes and for the citizen to understand what happened in the background. And we did some voting analysis. And at the end, the red points are the ones that's funded. They have much more support, and it justifies the cost. So it's sort of, it's much more on the top left of the chart. So.
Yes, so
traditionally there's no discipline. Yeah, there's a lot of discipline.
we did it.
Yeah, we did it differently. So that if you do want to propose a much higher cost, then you do need a support. Yeah. And we tried out different methods. Oh, sorry. We had a different method, and on the right is what was implemented, and on the left is what would have happened if it's the original method that all the cities are trying out. So the simple method, the majority method, only 7 projects will be funded, and only the inner city projects will be funded. And but using the method of equal shares that we calculate the vote differently, then all these smaller neighborhoods, they have smaller initiatives, and they also stand a chance. So 17 projects eventually was funded, and this was the result in July. And this goes back to our lab experiment that I talked about. We tried out different voting combination and how we perceive them. And we do realize that in a fair voting system, people feel satisfied, and no matter whether they actually win or not. I mean, if you have a majority voting system, people only feel satisfied if they win big. And that's another paper on the legitimacy of voting methods. But I think this is the part when.
Thank you so much, Josh. So Josh has done all the field work, and thank you so much for this, because it really created insights that I didn't expect. So, in other words, we can modify input rules and output rules to have better outcomes that are fairer, more inclusive, that people trust more, people are more satisfied with, actually cheaper, more cost-effective projects, a wider distribution of projects, distributed over the entire city. So there are a lot of advantages by changing voting rules a little bit. In other words, democracy can be upgraded by a lot. And there are further ways of doing that. In conclusion, I think we should be implementing more democracy, not less. Perhaps not the trend, but I hope this results will really change the way of thinking about our society. Democracy, I think, should be about pluralistic solutions. So, 17 projects does not mean that everyone likes all those 17 projects, but if everyone has 1 or 2 projects to be happy about, that's enough. Democracy should support collective intelligence and catalyze benefits for many. And we argue basically that in this complex, dynamical network world, that changes quickly, which is hard to predict and control, we should perhaps move from prediction to adaptation, from planning to co-evolution, from control to cooperation. There are many more ways to upgrade democracy, I'd like to say, participatory approaches that become fashionable, that could be supported more, like crowd sensing, crowdsourcing, crowdfunding, citizen science, hackathons, fab labs, makerspaces, open innovation, open source urbanism, government labs, citizen councils, participatory budgeting, as we discussed, participatory sustainability, participatory resilience, and city Olympics or city challenges. We actually propose to have a climate city cup, a friendly competition among cities in order to come up with better solutions and their implementations, but not just one solutions everywhere, but a diverse set of solutions that fits the local conditions and the cultural situation and the financial possibilities. So what I'd like to suggest is that this approach of digital democracy would be better than optimal. Of course, optimization sounds like this is best, but it's based on one-dimensional goal functions. And that is very restrictive, in particular for complex systems like societies. And just to make the test, I was asking ChatGPT as representation of smart AI systems about this question. Democracy has several, I was asking whether it sees any advantages of democracy over AI. And in fact, it mentioned a couple of them. I also told us that something like very powerful AI systems, some people would call AI bots, is perhaps not the best thing to do. So democracy has advantages like human judgment and empathy, accountability, public participation, adaptability, protection of rights. So that fits basically our bill pretty well. Conflict resolution, pluralism and diverse perspective, negotiation, compromise, legitimacy, learning, and evolution. So could actually think that it has already read the paper that we still have to write. And here is another example really to illustrate this point. Back to traffic control. And here, typically, you choose one goal, one objective, like minimizing travel times, and then you optimize for that and implement that kind of solution. But in fact, not only efficiency is important, also we care about sustainability and resilience, and that's not necessarily the same. Solutions could be looking very different. Classical optimization gives you 100% optimal solution for one goal, but it often poorly performs for other goals. That's the blue triangle. Perhaps we should go more for solutions that are not 100% optimal in one regard, but rather be highly performing in many different regards. So satisfying many goals very well. And this is the orange triangle. This is still a conceptual idea, but in the meantime, there is a paper called Democratizing Traffic Control in Smart Cities. And what we have done is we have introduced voting into traffic light control. So basically, we assume that drivers would have certain preferences for a number of different goals. And at each intersection, basically, this distribution of preferences would be considered by the traffic light controller. At each intersection, the composition of people would be different, and so the distribution of their goals would be different. And that means that each intersection, the traffic control is different, but it's adjusted to the people who actually want to have a good service. And as it turns out, this is actually producing highly performing solutions in many different respects. So it's basically increasing the size of the triangles, the area of the triangles, which basically means that those are solutions that are doing well in several regards. And I think this is exactly what we'd like now. So in conclusion, I believe we should rethink how we are making use of big data and AI in the digital age. And I think democracy is not an outdated technology. In fact, we should reinvent the democracy using those new opportunities in order to have a society and technology that works better for us. Thank you very much.